Hello, my name is Stefano Marchidis, and in this lecture I would like to give you a brief introduction about the logistics and general information of the DD2356 course, that is Methods in High Performance Computing. As I said, my name is Stefano Marchidis, and I'm going to be the course responsible teacher and examiner of this course. Together with me, I will have Professor Ivy Peng, who will also give some lecture and help me out during this course. We have also two TA, Jakob and Gabin, who will help us during the course. Together with these people, and also we have another large groups, our groups works on high performance computing, parallel computing, accelerator. We do research on many topics that we will talk about in this course, including MPI, parallel I/O, and the development of parallel application, for instance, for physics or engineering application. In our group, we're also doing research about accelerators and quantum computing. We are not covering these topics in this specific course, but we're having other courses offered here at KTH. What are the intended learning outcomes of this course? At the end of this course, you will be able to describe and list the HPC architecture design choices and what are the features of the supercomputing system. You will also be able to connect to a supercomputer, build and run codes on multi-core system and clusters. You will also be able to use HPC tools to measure and analyze the performance of the computer codes running on the supercomputer. And finally, you will be able to design, implement, and optimize parallel engineering application for HPC system using OpenMP and MPI library. So what is this course is about? Well, most importantly, this course is about making an effective usage of the most potent parallel supercomputer in the world, including the one that we have at the KTH. And why we do that? Well, we do that to solve problems in science and engineering. So what making effective usage of a parallel computing system entails? Well, doing this requires paying attention to every part of the parallel computer system, including the computing part, so the processor, the memory system, and the network. In addition, it requires a very rigorous and scientific approach to performance analysis, performance monitoring. So how do we measure performance? How can I say that I achieve a good performance? When I can stop my performance optimization? So these are two important questions that will come over and over in this course. The course objectives are to understand the sources of performance in modern architecture, so how we can improve our performance of our code. We are going to learn how to establish performance expectation. So these are not precise performance prediction, but we will need to be able to say, this is what we want to achieve. More than this, we cannot going to achieve. So we will be able to diagnose performance problem. So understand where it is performance bottleneck and try to address. We want to design algorithms and application to maximize the performance potential that we have in a given algorithm. And finally, we want to exploit parallelism at all levels, so at the processor level, at the compute node level, and supercomputer level. What are the prerequisites for this course? So what do you need before starting this course? So you will need a knowledge of the Linux operating system commands. And the reason for that is that supercomputers have and use Linux operating system. In addition, you will need to have a basic knowledge of C or C++ or Fortran. All the lectures and the assignment are going to be done in C++ and C++. However, if you want to use Fortran for your assignment, also you are welcome to use Fortran. In addition, it is very useful to have any knowledge of command line editors such as Emacs, VI, Pico, or Nano. Right. So these are editors that you can use within the command line. If you want to use an IDE, it's still okay. But keep in mind that you will not have an IDE installed on the supercomputer. That means that you can have a local IDE on your laptop or your workstation, and then move the file back and forth from the supercomputer. In addition, we have another course that is called DD2358, that is Introduction to Performance Computing. This is not a requirement, but obviously it is extremely beneficial if you take this course. But it is not a requirement, so you don't need DD2358 in order to take this course. How the course is organized? Well, we're going to have a series of pre-recorded video lecture, like the one that you're following now. And then we divided the full course in 3 modules. The first one is about performance modeling and benchmarking. The second one is about computing node, shared memory programming of a computing node with OpenMP. That is an approach for programming shared memory system. And then we will focus the last module on distributed memory programming with MPI. All the slides, articles to read, codes will be available online in Canvas. There will be 3 assignments with the pass or fail grades aligned with the 3 modules. The assignment consists of a submission of a short document in a PDF file using Canvas. Some assignment also includes the submission of a GitHub repository link with the code that you develop for the assignments. The assignments are completed preferably by groups of 3 students. Obviously, it's also okay, 1 student or 2, right? But we would prefer that you work in group, so you learn how to work in group and address all the issue in the assignment. However, you need to know that there is no penalty for working in a group of 3. So it's not that if you work in a group of 3, we expect you to do 3 times the work of a single assignment. So use it at your advantage, this work in a group. So it's important, starting from today, is to think about who you want to work with, and for the groups, and register your group in Canvas. So we automatically created 15 groups in Canvas. So join one of them and connect it to your colleagues and join the same group. If you don't know anybody you want to work with, please use the discussion page in Canvas to find partners and make a group. Together with these 3 assignments to pass the course, there is a final project that is compulsory. And this final assignment will give the grades of for this course. So this final assignment is graded A to F. It will determine your final grade, and there will be 2 major tasks. One task is the submission of a final report in the PDF format and the project presentation. The project will be presented at the end of the exam week. The topic is fixed and will be released during the 3rd module. Also, the final project is done in groups of 2-3 people. Together with the assignment, we will have individual Canvas quiz. So each person of this course will need to answer the question on the quiz, at least 95% of the correct question in order to pass the quiz. So how to pass this course? There will be 3 group assignment, pass or fail, individual quizzes for the module, and then a final group project that consists of a final report and the final presentation. You will be given access to the PDC, Dardel supercomputer. I applied for an allocation, so we have some computational time that is given by the PDC, KTH, Supercomputing Center. As a part of this course, you will learn how to connect and run jobs on the supercomputer and use for your assignment. So it's important that you have an account on the PDC supercomputer. On Canvas, there is the whole procedure to apply for an account on the PDC. So try to apply as soon as possible, just after this lecture. Keep in mind, all the instructions are on the Canvas page. So refer to this if you don't know. But there is a link where you apply and all the procedures. It's important that we ask you to do all the assignments and the final project on Dardel. So extremely important that from week 1 you have the procedure to access Dardel supercomputer, and you can play a little bit how to connect. You can learn how to connect, compile, and run the jobs. So how do I get help in this course? use the discussion page on Canvas as much as possible. We try to be responsive as possible. Try to avoid personal emails to myself or to the other instructor, because we receive several emails every day and we might miss. However, if you post your question on Canvas, there will be somebody from the course who can reply as soon as possible. So please try to avoid the personal emails to the instructors. Just put on Canvas. Don't be afraid if you think that the question is too simple. Don't worry. Just put on Canvas. I will get back to you as soon as possible. Also, if you have a problem, just detail which kind of problem, right? What is the error message? What you will try, so we can try to help you out in diagnose the problem. There are some course material and the textbook that you might use in combination with the slides that we provide. There is so first of all, most of these slides are adapted from the lectures and material by William Gropp at Urbana-Champaign, University of Illinois Urbana-Champaign. But also there is a very nice textbook that is available online on the KTH library. You can log in your Tori account and have access to this high-performance computing book, whose one of the authors is very famous, is Thomas Sterling. So this is one textbook that comprise pretty much all the material around supercomputing. So this book by Thomas Sterling, Matthew Anderson, and Maciej Brodowicz. The second module, I strongly recommend a recent book on OpenMP, mostly on advanced feature. Its name is called Using OpenMP, The Next Step, by Ruud van der Pas, Eric Stotzer, and Christian Terboven. Finally, the third module will be about a message passing interface, or MPI in short. There will be two reference textbooks, the blue one and the green one, both led by Big Rob, a professor at Urbana-Champaign. The first one is using MPI, is more basic, and then the second one on most modern advanced MPI feature. We have three modules as a set, and the tentative courses outline. The common theme for this course is use as simple as possible models of a computation as an execution model to gain insight into performance issues. So we are going to use performance model to diagnose issues and design a code for performance. So how do we know that there is a performance problem? If you have a code, you're probably very optimistic and very proud of it, and you say, oh, my code scales quite well. So the real question that I have for you is really efficient. And how do you know that? How can you tell me that the code is efficient? So my question will be, how do we know? How do we compare? And in this course, we will develop techniques to answer this question and to guide you in the development of HPC codes. So these are the last slides I have. So welcome to the course. I'm looking forward to working with you all. Talk to you soon.